Hello everyone, I am Nirmal Mandal and my roll number is 350001211038 and I am the final year student of Computer Science and Engineering Department at Ramkrishna Mahato Government Engineering College. Today I will discuss on the supervised machine learning. So first of all, let's see what is the supervised machine learning. Supervised machine learning is a type of machine learning where algorithm is trained on labeled data. This means that the data used to train the model includes both input features and corresponding correct output values. After seeing the definitions of supervised machine learning, let's search important points are the key concepts of supervised machine learning. Here are the several key concepts of supervised machine learning like features, target variable, training data and testing data. Let's discuss one by one these key concepts. First, features. Features, these are the independent variables or attributes of data. What is its role? They provide the input variables to the model for making predictions. And it's the example like in a house pricing prediction models, features could conclude the square footage, number of bedrooms, location, etc. And next, see the target variable. The target variable are the dependent variable or the output that you want to predict. It's the value that the model learns to predict based on the input features. One example of target variable is like in the house prediction model, the target variables are the price of the house is the target variable. Next one is training data. Training data is a subset of your data used to train the machine learning model. The model learns pattern and relationships between features and the target variables from data. It's example like in a spam detection model, the training data would consist of emails labeled as spam or not. And the last one is the testing data, a separate subset of data used to evaluate model's performance. It helps to access how well the model generalize the unseen data. In spam detection model, the testing data would be a set of emails not included in training set to check model's accuracy. So here are the some key points to remember. It is crucial to have a representative distribution of data in both training and testing sets to avoid biases. The quality of data significantly impacts the model's performance. Overfitting occurs when model performs well on training data but poorly on testing data, indicating too complex for given data. Next, let's see the types of the supervised learning. The supervised learning can be categorized in two types. First one is the classification and second one is the regression. What is the classification? Classification tasks involve the predicting a categorical target variable such as whether an email is spam or not. And on other side, the regression tasks involve the predicting a continuous target variable such as the price of house prediction. Let's see the data preparation and the processing. Data preparation is a crucial step in the machine learning pipeline. It involves the transforming raw data into a suitable format for analysis. Let's look into the process. First one is data cleaning, the process of identifying and correcting errors, inconsistencies, and missing values in a data set. It have a large importance, ensure the data accuracy and reliability, improving the model performance. For data cleaning, we use several techniques like handling missing values, outlier detection and treatment, noise reduction, inconsistency handling. Let's see the next one, feature scaling. Transforming features to a common scale prevents features with larger scales from dominating the learning process, improving model performance for algorithms sensitive to features scales. In feature scaling, we also use several techniques like normalization, standardization, and many more. The last one is the data transmission or transformation. So, the process of transferring data from one location to another. It enables the data sharing and accessibility. It also use many techniques like network protocols, TCP/IP or HTTP, data compression, data encryption, and many more. Let's see the features engineering and selection. Feature engineering is a crucial step in machine learning that involves the transforming raw data into features suitable for machine learning models. It encompasses several key processes like feature extraction, feature selection, feature transformation. Let's see one by one. Feature extraction, creating new features from existing ones. Its goal is to capture relevant information and reduce dimensionality. For feature extraction, we used several techniques like statistical methods like PCA, LDA, and domain specific knowledge, and many more. The next one is feature selection, choosing a subset of relevant features from original dataset. It improves the model performance, reduce overfitting, and simplify the model. And the last one is feature transformation, modifying existing features to improve their suitability for the model and to enhance feature distribution, handle outliers, creating new representations. In right hand side picture, we can see there are many features engineering process. Like first one is encoding, features handling, bucketizing, transformer, normalize or standardize, feature crossing, PC or principal component analysis, and one is LDA linear discriminant analysis. Let's discuss about the model selection and evolution. Choosing a right model for a specific problem, it is crucial to achieving the good performance. So model selection, there are several model selection like we can select models like logistic regression, decision trees, support vector machine or SVM, k nearest neighbor or KNN, and random forests. Every models has their evolution matrices. Like logistic regression has their accuracy, precision, recall, F1 score, and the decision tree have the accuracy, precision, recall, F1 score, and entropy. Support vector machine have accuracy, precision, recall, and F1 score. The KNN or K nearest neighbor have accuracy, precision, recall, F1 score. And the last random forest have also accuracy, precision, recall, F1 score, out of bag error. In right hand side, we can see the model selection. We can select a model based on the probability, random train and test, and resampling. In probability, it also divided into AIC, BIC, MDL, and for resampling, it also divides into cross validation, bootstrapping, many more. So, commonly used supervised machine learning algorithms. The various supervised learning algorithms are widely used in different applications. In linear regression, we predicting a continuous target variable based on a linear relationship with input features. In logistic regression, we predicting a binary categorical target variable using the sigmoid function. Sigmoid is an important function in machine learning. The sigmoid function value is 1 by 1 plus e to the power minus x. And other like algorithms like decision trees, it creating a tree-like structure to classify or regress the data based on the decision rules, and it helps to decides decides or classify the inputs or data set. And the next one is the support vector machine. It is very powerful algorithm, support vector machine or SVM, finding an optional hyperplane that separates the data points into different classes. It also classifies the data sets or data points. So generally, the machine learning is divided into three parts of learning. The first one like supervised learning, unsupervised learning, reinforcement learning. In supervised learning also further classified into regression, classification, unsupervised learning classified into clustering, learning also have the control. So hyperparameter tuning and optimization. Hyperparameters are the parameters that are not learned from the data but are set by the user. So hyperparameter is very important. Hyperparameter tuning is very important to increase the accuracy of the model or to reduce the loss function of a model. There are several hypertuning and optimization like grid search, random search, Bayesian optimization, gradient descent, the most popular one. What is grid search? Trying out range of hyperparameter values, choosing the combination with best performance. And the random search, random sampling hyperparameters values and choosing the combination with the best performance. And same as the Bayesian learning, also probabilistic model to find the best hyperparameters efficiently. And the gradient descent iteratively adjusting the hyperparameters to minimize the loss functions. So in this, the left hand side, we can see that there are the raw data in feature engineering or data cleaning or data extraction or by data transformation. We divide this data into the training portion, validation portion, and test portion. From the training data or training concept, we build the model, then training results. We get a training results, and in validation, we also these models and we get also the training results. And after getting this training result, we can get loss. To reduce this loss, we use the hyperparameter tuning in iteratively. When the loss is minimum, we set this hyperparameter as the global. Then after performance the test result and compare the test and it will be the minimized ones. So real world exam applications and case studies. Supervised machine learning has wide application in various industries and solving the diverse problems. Let's see the some examples like fraud detection, customer segmentation, medical diagnosis. In fraud detection, we're detecting the fraudulent transaction using the machine learning models. Also see the spam in email. Is the email is spam or not? Customer segmentation, the segment customers into different groups based on their behavior and characteristics and their interest. We can group it. And the last one is the medical diagnosis. It assisting doctors to diagnosing disease based on the patient data. Okay. The the last one is the conclude. The last is conclusion. Let's conclude and the future trends. Conclusion. We see that the intersection of deep learning, explainable AI, data privacy, and the security is shaping the future of artificial intelligence. While deep learning has the demonstrated remarkable capabilities in various domains, its black box nature poses challenges for trust adaptation. Sorry, and the explainable AI focus on making machines learning models more interpretable and understandable to the humans. And this the last data privacy and the security, it's addressing the ethical corners related the data privacy and security in machine learning. So if we see that the deep learning, why occurred this deep learning over the machine learning model? We see that in 2005, we see that the in Facebook or Meta, the data generates exponentially, and in this growth of huge data exponentially, we cannot handle using the machine learning models. After the amount of data, size of data, it gives a similar accuracy. But in deep learning models, we can increase the data continuously. And let's look the if references, NPTEL lectures, supervised machine learnings, and the supervised machine learning Google developers blogs.